My name is Samantha Wingate, and I will be presenting a PowerPoint about stars. Today we're going to learn how stars are created, how their life ends, and what the classification of stars is. First, we need to know, what is a star? A star is a sphere of very, very hot gases. The gases burn so bright we can see stars from planet Earth. Because there are so many, we look for patterns of stars and name them. For example, the Big Dipper is a constellation of 7 stars. The Big Dipper looks like a giant ladle in our night sky. The closest star that we have is the Sun. The Sun is the only star in our solar system. All of our planets, comets, and an asteroid belt revolve around the Sun. The Sun could be called a yellow, medium-sized star. All stars are classified according to their temperature and how bright they are. Hotter stars are usually blue or white in color, and cooler stars are red or orange. Another way we classify them is according to age. Younger stars are called dwarfs. Older stars are named supergiants. Young stars are usually red, white, or yellow. Older stars are colored red or blue. Our Sun would be called a yellow dwarf. This chart shows a timeline of our Sun's life. As you can see, the older the Sun gets, the bigger and redder it gets. Keep in mind, this chart is over billions of years. Since our Sun is an average-sized star, we can apply this chart to other average stars. It takes billions of years to form a star. They are birthed in giant clouds of gas and dust, and once there is enough gravity, the cloud will collapse on itself to form a rotating gaseous ball. The new star will continue to heat up until a required temperature is achieved to create energy from a process we call nuclear fission. The energy is released as light that we can see, which will continue to burn for billions of years. This picture is a place where stars are born, called the Eagle Nebula. The giant pillars are the plumes of dust and gas from where stars are birthed from. As the star begins to run out of gas to burn, it will reach the end of its life. The star will first expand into a red supergiant. The picture is of Betelgeuse, a red supergiant that is almost to the end of its life. Once the star is done expanding, gravity will pull the star inward, then the star will explode. The size of the original star determines how long it burns. The bigger the star, the more energy it has to burn. Therefore, the star will run out of energy quicker if it's a bigger star. This is the picture of a Crab Nebula. This was a star that exploded 1,000 years ago. Today we have learned how stars are born, how their lives end, and how we classify stars. Thank you. Where did it go?